Hey everyone, welcome back to class. So in this particular lecture, we're going to be talking about these concepts called variables, or how we're going to measure and understand our ideas and our arguments and our hypotheses, how we're actually going to statistically operationalize them. So we'll talk about some of those key terms. This is coming on the heels of our lecture on the ideas on causality, creating causal mechanisms or connections between our variables. In that lecture, we used a little bit of that language of understanding X, or our independent variable, and Y, our dependent. We're going to get in and give you guys the terminology a little bit more concretely for that in this particular lecture. And we're going to give you some examples to work with in terms of the confounding or control variables that you need to be aware of when we're talking about causal relationships. So let's get started. What are variables? Variables are factors, elements, or concepts that can be changed, controlled, or measured. So we want to think about variables as the concepts in our arguments and our hypotheses. They're going to be the things that we're trying to understand the relationship between. They're parts of our data set that are going to be measured and then analyzed in order to understand our arguments and ultimately understand our theories about the world. They are essentially how we operationalize or we move forward with the concepts that are in our hypotheses, which are our arguments about these phenomena. So there's a specific set of language that I want you guys to get comfortable using when we're talking about statistics and talking about establishing causality within this quantitative framework. Our cause is going to be called the independent variable, and this is our X variable. We're going to say that our cause is going to be related to our effect, right? Our effect is then our dependent variable, or it depends on our cause. Our dependent variable is now coined Y. So you'll see a lot of these sort of figures moving forward where X with the directional arrow is causing Y. So this idea of X and Y, I want you guys to kind of reiterate this and rewrite it in your brain. So when we get to this part of the lecture and you're writing in your notes, I recommend you write it down a couple times. Rewriting things helps you solidify these concepts. Our independent variable is X. Our dependent variable is Y. Our independent variable is the cause. The effect is our dependent variable. This framework of X and Y is going to be super foundational for you when you move forward in understanding these statistical paradigms and our understanding of quantitative analysis. It helps us then translate our ideas into functions, which we'll talk about at the end of this lecture. And so this framework of X and Y is very important. So we can additionally use the language that X is a function of Y. So our cause is a function of the ultimate effect. What are some examples of this? An increase in political knowledge, which is our X, leads to Democratic Party ID, which is our Y. That was an earlier example that we used, right? Another similar kind of logic we can use with the X's and Y's is identifying as a woman legislator, that's our X, or independent variable, leads to more progressive legislative policy, which is our Y, right? So the independent variable there is woman legislator, and that changes or causes different kinds of policy, which is our Y. So this framework of X and Y, you should be able to translate it to every working hypothesis and hypothesis that you have, right? This should always be, if you're struggling to find your X and your Y, then you're not talking about causality in your argument. So it's actually a good gut check. If you can't determine what your X and Y are, then you likely haven't gotten specific enough. So we know that we want to understand the relationship between X and Y, but we also know that sometimes there are other things that affect the relationship between X and Y, and that changes our ability to make understandings or understand the truth between X and Y. And those are third variables that we talked about already, called control or confounding variables. That third variable we're going to call Z, and it's going to affect the relationship between X and Y, and we need to find it and understand it and either get around it or control for it. Again, like I said, we can control for these intervening factors statistically and sometimes theoretically or in our actual research design. But we'll talk about the different kinds of ways that our Z can affect our understanding of the relationship between X and Y. The first kind of way that Z can sort of muddle your understanding of X and Y is an intervening variable or an intervening confounder. An intervening variable is where X or independent variable causes a change in Z, and then Z is actually what's causing the change in Y. So a good example of this would be levels of education, changing how much money somebody makes, and then that money is actually what's changing how much somebody spends. So our original hypothesis likely would have been that levels of education, maybe still a directional one, a higher level of education leads to a higher level of spending. But really what's actually happening is it's not the levels of education that's causing increases in spending, it's that the levels of education cause an increase in income, and income is actually causing the increase in spending. So income is a really good example of a Z or an intervening variable that's getting in the way of our understanding of our original X and Y, which is levels of education and spending. There's also spurious or spurious confounders. So spurious confounders are a Z that affects both X and Y independently. A really good example of this was the ice cream and crime rates example, where the Z, the time of year or the temperature, was changing how much ice cream was being sold or how many murders were happening. But it wasn't the case that levels of violent crime was causing increases in ice cream sales. It was just that the time of year was affecting both. So we see that Z has two directional arrows pointing at changes in X and Y. So it seems like there's an increase in crime rates and as crime sales increase. It seems like there's an increase in crime rates as ice cream sales increase, but really what's actually happening that we determined was that there's an increase in temperature that's causing both. And that increase in temperature is our Z or our spurious variable in that case. The last one that I want you guys to think about is this idea of an extraneous variable, right? So an extraneous variable is a Z that causes a change in Y and is an outside variable that's associated with our dependent variable that we're not accounting for at all. So we're trying to understand hours spent training and how it affects. So say this is like a basketball player, a set of basketball players. And we're trying to understand how hours spent training affects the amount of points that they're scoring per game. So we want to know if training affects points per game. Really, actually, what's causing it is this idea of hours spent stretching. So stretching might actually have a bigger or more determining impact on the average of points per game, but we're not accounting for that because we're only looking at hours spent training and how that affects average of points per game. So the hours spent stretching is an extraneous variable. So there's a typo down here on the bottom. It's extraneous variable, not intervening. So extraneous variables are when there's a Z, which is hours spent stretching, is actually affecting our Y, which is average points per game, but we're not accounting for it in the X and Y framework that we've set up, which is hours spent training and average points per game. So let's kind of zoom back out a little bit and understand all of this within the framework of quantitative analysis and moving you forward kind of in your statistical understanding of X and Y. So functions allow us to mathematically capture our ideas about the relationships between X and Y. So hypotheses are going to posit systematic relationships between variables, and these relationships are then expressed as functions. For example, we can hypothesize that an individual's productivity is related to coffee consumption, or productivity is a function of coffee consumption. So we can reframe that language to understand the functional form of a relationship. So in mathematical terms, a function relates an outcome variable Y to one or more inputs X. So the mathematical notation for that is Y is equal to F and in parentheses X. So that is read as Y is a function of X. So whenever you see F and then the little parentheses with something inside of it, that means is a function of. So we can use this mathematical framework to then kick the door open for us to understand the functional form mathematically of the relationships between the phenomena that we're studying. And so that paradigm or that framework is called statistical learning. It's the framework that we use to move forward statistical learning, as we're understanding the functional relationship between X and Y. So let's go back for a key term check. We have independent variables, which is our X's, that's the cause. We have dependent variables, which is our Y, that's the effect. We have control variables. There's 3 different kinds of these confounder controls. They're intervening, spurious, and extraneous. We also have this framework of understanding functions, or how X is a function of our Y. And then or Y is a function of our X, excuse me. And then that kind of solidifies our understanding of statistical learning as a framework for understanding our theories about the world. So this is going to wrap up our module 1C, and we're going to move on to part D. And that's going to actually be concretely operationalizing these measures and understanding a little bit of how data mechanics work. We're going to start with Excel and with a guest lecture from Professor Mario from your guys' department. He's the current chair. And we're going to move on from there to talk about this framework of operationalization in a concrete way.